Hi there. Today I will be showcasing the demo for the object and object detection using the YOLO model. For that, we will first run the YOLO model using the PyTorch interface, and then we will be converting that PyTorch model to ONCS runtime. So, and then we will be comparing the result for the object detection and how it will perform. So I have prepared some basic setup, which includes the loading of the preloaded model, and then there is a image. Also, I have developed the YOLO pipeline using the cursor ID, and there will be a requirement of txt, which will be used for the packages will be used. It consists of the five packages. First is the torch, which is for use for the PyTorch, and there will be the Ultralytics model, which is used for loading and running the YOLO model, and there will be the onks and onks runtime for conversion of that model to the onks format, and there will be the open cv which will be used for the marking the objects with the boxes. Let me just create the environment first and install my dependencies. Okay, so our dependencies has been installed. And then now let me use this file. Okay. Also, for I have also created the output folder also, which will store the output of that. And let me give you a brief overview of the pipeline, how it's working. So here we have just imported the basic packages that we need, and we have set the path for the images, models, and the output. Now we will there as the a YOLO, which is trained on a data set which is called the COCO, which represents the common object, and which includes in our like daily life, and the dictionary with the and there will be an color for each class to get its unique bounding box. So these are that thing. Now we will move to that function draw the draw box. It is used for drawing the rectangular boundaries around the object it detects, which uh, which is takes the coordinate for the object, like top left, top right corner, and the bottom right and the bottom left corner, and use the CV2 library to draw the rectangular and put text over it, like the name of that object and how it is measurable. Then there is a compute IOU, which is used for the measuring the overlapping of boxes. And then we move to that is the run pytorch. This is our main code which we use to run the pytorch model. In that we have loaded the model using that YOLO, and the function which is used is this. It will load the image using the path. We have set the confidence here is like the default confidence for the YOLO is like 25 percentage. So it will use the at least 25 percentage. So it is like how object is likable to that. So for example, if something is it is detecting, and we check the if the confidence score is greater than equal to 25, it will mark it as that. So to at least for an object to be detected, it will be at least 25% matching. So these are the basic setup of how it is be loading the model and how result will be used. Then here in this piece of code, we are getting the coordinate of that box in like x1 x2 format. After that, here we will be using the numpy to convert the pytorch tensor to the numpy format. And here the after it loads and reads, it will draw the boxes and save the output images uh, here. So this is a pretty much overview of the pytorch model. That now that comes to the export to ongs, which will used for converting the model. The output format will be the ongs, and we will take the expected size of images to the 640 pixels, and the offset will be the 12. Also, we need to clean up the redundant operation to make the model learner. So we will be keeping the simplify equal to true. And also for the input size, we don't allow the variable size and need to keep it fixed. So we will be setting the dynamic equals to all. So this one line does the huge amount of work. It will trace through the mathematical operations of PyTorch and rewrite them into the universal ONGS format. So after that, this is the pre-process method, which is preparing the image for the ONGs. As earlier mentioned, we will be fixing the size, so it should be according to the ONGs format. Next, we move for the post process. Post process will be used for the predicting the output of it. And then finally, there is be the run ongs method used, which using the interface sessions and the ongs converted model. And the provider is the CPU execution provider, which will be used for loading and running the model. For labeling that object, we will here the use is the Coco classes, which we have defined earlier on the initial stage. So yeah, this is the pretty much walk through the code. So I have also like created some functions which will be like using this will compare the images from the ongs and the PyTorch, and it will create an side by side overview of that. So yeah, that's a pretty much overview of the code. Let me do the actual demo and run the model file, so it will provide us the output. So yeah, the execution is done, where we also shows the verbose logging here for the PyTorch. It is detecting that the image containing this will contain the two giraffe with the confidence score of 94 percentile. Then there will be the two cars of the 88 and 84 percentile, and a person with a 30 percentile confidence score. Then we ran that same model using converting into the ONGS format, and we can see here the confidence score from the ONGS interface. The person will be detected as 36%, and there will be the two cars for 88 and 89 percentage, and also the giraffe with 95 and 94 percentage. So comparatively, they are similar. Let, let's take a look. This is the ONGS formatted, and here will be the result from PyTorch, which showcase that it correctly identify the cars, giraffes, and the person. And here's the result for ONGS. And when we see the comparison over here, so yeah, it is mostly the same with almost identical. ONGS and PyTorch perform the almost identical detection. But if we can see the time here, the PyTorch use the 130 milliseconds to detect it, and the ONGS version uses the 42 millisecond. So the ONGS format is comparatively faster than the normal PyTorch model. And also it's including the average IEO, whi- which is between the PyTorch and ONGS, which is the 0.962. Detection is 5. Yeah. So based on the how it calculated, so the both models correctly detected the giraffe, car, and persons in the image. But the ONGS model will be the faster, uh, with average IEOU is 0.96, which confirms the conversation was lossless, and uh, it will be the production ready. So yeah, that's from my side.